Let us discuss about charts and chart types. Actually, this is in continuation of visualization topic, data visualization, and the importance of data visualization which we are taking. So, we need to understand that charts are one of the strongest tools for data visualization, visualizing your data. So, let us quickly look at different types of charts. I have this diagram which I have taken from Abela extremepresentation.com. So this depicts different kinds of charts. Let us look at the different kinds of charts quickly. We have column chart, bar chart, line chart, circular area chart. Then we have histograms. Then we have scatter chart, area chart, waterfall chart, and different variations of them. So let us look at this. Let us say I want to establish relationship of two variables. I may go for a scatter chart. Of three variables, I may go for a bubble chart. Let us say I want to show distribution. A single variable with few data points, I may go for a column histogram. Many data points, line histogram. Two variables, scatter chart. Three variables, 3D area chart. Let us say I want to show composition, which is static. I may go for a pie chart if I want to show the single share of the total. I may go for a waterfall chart if I want to show accumulation or subtraction to total. I may go for stacked 100% column chart with subcomponents if I want to show components of components. Similarly, if I want to show composition changing over time with say a few periods and only relative difference matter, then I may go for stacked 100% column chart. If I want to show relative and absolute different matters, I may go for stacked column chart. If the composition is changing over times with many periods, then for relative difference, I may go for stacked area chart. For relative and absolute difference, I can go for stacked area chart. This is 100% stacked area chart. This is stacked area chart. Normal. Let us say I want to make comparison. Okay. So, and that comparison I want to make among items. And let us say those items are two variables per item. I will go for this column chart. So I have one variable per item, let us say. For that, if there are many categories, I may go for table or table with embedded charts. If I have few categories but many items, I'll go for bar chart. Few categories with few items, I may go for column chart. Similarly, if I want to make comparison over time with few periods, and you have a single or few categories, go for a column chart. Many categories, go for a line chart. If you want to make a comparison over time with many periods, if it is cyclic data, go for a circular area chart. If it is a non-cyclic data, go for a line chart. Similarly, I have used this website atlassian.com, which actually depicts charts for data visualization topics. So we can, by looking at this heading, we can connect visualization and chart are interconnected. Rather, charts are essential and major tool for data visualization. So we'll go look at the various kinds of charts mentioned here in this atlassian.com. The first one is the bar chart. Here you are seeing the user types and the purchases they are making. Okay, so you have existing users, new users, guests. Okay, so these bar charts, if they are having vertical bars, then they'll be called as column charts. So you see here line chart, there is a what it is showing is changes in value across continuous measurement. Like for example, here the months are changing and the exchange rates are changing, and this is the line chart. You see here scatter plot. Okay, so this scatter plot is showing two values, right? Numeric values. One is plotted to x-axis, the other one is plotted to y-axis. Okay, so per variable there will be two values, which will be x-axis value, y-axis value. And scatter plot usually are used to depict the relationship between plotted variables. Is there a correlation? Is it a weak correlation or a strong correlation? Is there a linear relationship, non-linear relation? Such kind of things can be used for scatter plots. Scatter plots are also used for identifying the outliers. Box plots, these are very interesting. So let us understand what this block plot consists of. You see 5 lines, 1, 2, 3, 4 and 5, and you see a box here, and you see a whisker here, right? So these kinds of box plot depict 5 things: minimum value, maximum value, first quartile, third quartile, and a median. And you can see here outliers also. Here also you can see here outliers also. So basically box plots are used to summarize the distribution of values with measured groups. You are seeing here what it's called as a histogram, right? What it is showing here, the response time and the frequency. So the length of the bar in the histogram actually indicates the counts of the data points. And their pattern demonstrates the distribution of variable in your data. You see here stacked bar chart, right? So actually these are the modifications of normal bar charts, where you are having stacks, smaller bars, which is for subgrouping kind of thing. You can see here this bar chart basically is for what? It is for showing the revenue at this different locations. And now the subdivisions are indicating whether it is for clothing or equipment or accessories. These are the examples of grouped bar chart. So we are having sub bars which are placed side by side in the form of a cluster. It basically allows comparisons of subgroups also. And this is the example of our dot plot. You can see here different experiments, their performance scores here. A dot plot is like a line plot, except there is no line drawn. If you connect the dots, that becomes a line plot, right? This is the example of an area chart. What basically an area chart indicates how a total has changed over time, but it also shows its component distribution contribution over change. You can see here guests and subscribers, right? And the months, varying months, and the increase or decrease. I'll skip this. These are the bubble charts. Again, they are similar to scatter plots, but you are seeing the sizes are bigger. Usually here I had mentioned here in this plot what is a scatter chart, why it is used, that kind of thing, right? And while mentioning the scatter chart, I had said that it shows relationship between two variables. But if it is a bubble chart, it will show relationship between 3 variables. Skip this, skip this. This is the heat map. Okay. So this is the pie chart. This is a funnel chart, very interesting, right? You can see here you are seeing this funnel. Usually the funnel charts are shown in a business context or marketing context, and what you see here is uh, it is tracked in a pipeline flow, how changes happens with the track process as per the width of the funnel at each stage. The funnel gets tapered, right? And this tapering also shows the behavior. Say for example here, related to a website, these are the 100% impressions, then the clicks are 50%, actual conversion is 10% kind of thing. Okay, so these two have given us some idea regarding the various kinds of charts or typical charts which are there, like scatter charts may be there, bubble charts may be there, bar charts may be there, histograms may be there, heat maps may be there, right? But visualization through charts can start with tabular data also. What are the advantages of tabular data? Precision representation is possible, scale representation is possible, and suppose we right justify the numbers which will be communicating better the order of magnitude difference. A multivariate visualization is possible. A heterogeneous data can be shown, compactness can be brought. What are the best practices whenever I am using tabular data? You can order rows to invite comparison. You can sort by size or date, or you can do lexicographic sorting. You can order columns to highlight importance or to show pairwise relationship. You can right justify numbers to show uniform precisions. You can emphasize with font and color to highlight important entries. You can avoid excessive length column descriptors. Say for example, this is my data, right? Which what this data is showing: country, area, density, birth rate, population, mortality, GDP. Suppose I follow these best practices. Okay, ordering, sorting, right justify, emphasize, avoid excessive length, all that. So I may reorganize this table in this form. What I am seeing here, the columns have changed now. After country, here it is area. Now after it country, it is showing population, and everywhere you are seeing here bold things. So bold things are what? These are the highest values. So I can immediately point out that China has the highest population. I can immediately point out that Russia has the highest area. Japan has highest density. Afghanistan has highest mortality. Australia has highest birth rate, kind of thing. United States has GDP, kind of thing, right? These are the various forms of line charts. And line charts, you know that there are a lot of support libraries in Python and R. For example, Python has matplotlib package. Now I also know that there is a similarity and a subtle difference between dot and line plots, and usually they are used to depict relationships like in the form of y is equal to f of x. Dot plots basically show the data points. Line plot show the uh, continuous function. What are the advantages of line plot? They show interpolation and fitting, which makes prediction more easier. They inherently show dot plots because line plots are what? Dot plots only connected over line. What are the best practices with line charts? They show data points, not just fits. So ensure that one does not overwhelm the other. Show the full variable range if possible. Admit uncertainty when plotting averages. Uh, Here it is highlighting the box plot, which record the range and distribution of values at a point with a box. Uh, what this box plot is showing, the quartiles and cut at median and so on and so forth. You remember this discussion, right? The five lines. This is the median. This red color line is the median. This horizontal line is minimum value, maximum value. And these are the first quartile and the third quartile. You can see here from this box plot, the median weight is growing on increasing with height. As the height increases, the median weight increases, but not necessarily the maximum weight is being increased, right? You have here scatter plot, and you see here the size of the dots is smaller here and it is bigger here, so it is giving more clarity, right? More details, so depending on the dot size. What this scatter plot is showing: the normal for red color, overweight for green color, obese for blue color. So it may, so color coding is an option here. Scatter plots are used whenever we have large number of data points, thousands of bivariate two-dimensional points. It shows value of every data point. What are the best practices? The dot size should be proper. So usually what people do the mistake is they choose the size of the dot bigger. .14. Here only it has given the example. Dot size is smaller, it is giving more clarity than the dot size being bigger. You can see here figure 6.15. So if you have overlapping dots, they'll be obscuring the scatter plot. Yeah, whenever you have a larger data set, by reducing the opacity of the dot. So here you have reduced the opacity, right? So it is showing the clarity more clearly. But if you instead go for a heat map which has color coding, it is a better depiction or representation. Now we have bar plots and pie charts. What they indicate? They indicate the relative proportion of categorical variables. They indicate the relative proportion of it. For example, these are our pie charts and these are our bar charts. So what these pie charts are indicating, uh, US presidential election results 2004, 2008, 2012, and it is showing clearly who is the winner. This is regarding the pie chart. And we know that blue is for Democratic, red is for the Republicans. Pie charts are usually better for showing percentage of totality. What are the best practices for bar plots and pie charts are directly label slices of the pie. Use bar charts to enable precise comparison. Scale appropriately depending upon whether you seek to highlight absolute magnitude or proportions. Okay. So you can see here this stacked bar chart example. And what is this bar chart is showing? This is regarding the Titanic ship. People in Titanic ship maybe had first class ticket or second class ticket or third class ticket. And I can see here that more number of people were died in the third class. So you had bet more chances of survival if you bought a first class ticket or a second class ticket. So this is showing the proportion ratio actually. This is showing the number. What is the ratio? I can easily understand the ratio, right? In first class, more survivors there. In third class, more deaths were there, like that. Next comes the histograms. So variables are there, frequency distribution is there, peak is there, mode is there, mean is there, symmetric distribution is there, or skewed distribution is there, where it is bimodal. All those aspects will be depicted with the help of histograms. Okay, this is actually a time series data for US elections, and this depiction is better, right? The right side depiction is better. What histograms are used for? They are used to plot observed frequency distributions when the variable is defined over a large range of possible values relative to the n observations. What is the challenge in building histograms is the choice of number of bins. Too many bins, a few points. So too few bins, you will not see the details. So these are the histograms of a given. They look quite different depending on the number of bins you will be selecting, right? So if you have a large data set, you can go for many bins. But if you have a smaller data set, you should have the balanced number of bins. Here, if you see this frequency histogram density, so we have just changed the label, right? Rest of the things are looking similar, but it is showing more clarity. So instead of histograms, you can go for CDFs, cumulative distribution frequencies, for showing the tails, because histograms are better suited to show the peaks. What are the best practices for histograms? Turn your histogram into a PDF, probability density function. You can use cumulative distribution functions. These are the data maps, color coded. Right, this is all about the charts in brief, which are an effective tool for visualization.